Hello, I'm in the hangar making my METAR map. If you're not familiar with a METAR map, stay tuned. We're going to go through this step by step on how to make one of these METAR maps.
This channel is about working on aircraft and flying those airplanes. So come take a seat and let's go for a flight.
Now, if you're not familiar with what a METAR map is, it is a Wi-Fi enabled map that has LED lights in airport locations and will report the VFR conditions and the ceiling, and you can add, I believe you can add wind to some of these, like you can set a particular wind speed and it will change the color. So if you don't want to fly anything higher than, like, say 25 knots, that airport will light up for you and be represented on the map. So what I've had to do is I've got some old sectionals here. Those are rather large. So I've used two sectionals for Seattle. One for the front side, one for the back side. So that has everything from about Canada all the way down past Portland. So it's roughly 4.5 feet by 3 something thing. So I had to go get a 4x8 sheet of this stuff and cut it down. And then what I did was I carefully glued the top part of the sectional down with some it's contact adhesive, but it's, I think you could use Super 77, but I found the stuff, it was made by Loctite. It was like $5. So I've glued the top section, and I had to carefully cut the very top of the bottom section when you flip it over, and then pinned it to where it would line up correctly. Then I took a little bit of that Loctite into a cup, and with a Q-tip glued the very, very top of it together so that it would stay in place, and then carefully worked my way down and worked out all of the map so I wouldn't get any creases or make it look nice. So now we're in the process of punching the holes that the LEDs will come through on the map. So this is what one of the little LEDs look like. It comes in a string of 50. This particular stuff was sourced from Amazon because they've got everything. And the control board I'm using is an Arundu. If you're not familiar with some of these small computers, some use Raspberry Pis. There's another manufacturer out there called Rock. I'm not familiar with programming that one. But the Arundu has a GitHub source for all the information. And you can look up a guy by the name of Ken Harmon. I believe that's his name. And I bought the kit from him and had to go program it. It's a little in-depth, as it were. There are some other ones that use a web-based browser kind of interface, and all you have to do is just basically plug in your airports that you want to use, and it will spit out the code. With Mr. Harmon's little device, a little more fidgety with some of the code and getting it to work. So, but we're going to go through and kind of go through the rest of how to put the map together in a larger format like this. These LEDs are not spread far enough apart. That's why this one's cut out. I just needed it to size the hole. We're going to punch all these holes, and then I'm going to have to go through and solder the lengths between the sections because the airports are spaced further apart than the LEDs can handle, and I don't want to skip LEDs. I want to use all 50 of them. So now that I have the map like physically mounted onto the board, I have done some pre-planning and figured out where my airports are going to live and how they're going to be connected. What I did was to SkyVector and printed out a section of basically the shape of little version, big version, and identified the 50 airports that I'm going to represent on this map, and then made a little trace. So this will actually be the wire hookup on the back of the board for the map. And so this is my guide to going through the airports that I'm going to be using, and how I'm going to open up the hole in the foam board is I've tried a couple different things. A drill motor will just tear up, if you use a drill bit, will just tear up the map. I've tried, I've got a really fancy punch set, and that did quite a lot of damage to the back of the board because the punch set is kind of flared out, if you will. But believe it or not, the cheapest hole punch set that I have actually works the best. So what I have to do is locate each airport that I'm going to use on the back side of the foam board. And what I'm going to use there is a hat pin, and I'm going to poke into the airport center, and as it comes through the back side, I'm going to take a magic marker and put a little dot. Then what we do is flip the whole thing over, and then I have a little backing plate here. Then I'm going to flip the map so the map is facing onto here, and we're going to punch through the back of the foam through the map, and that's the simple Harbor Freight, I guess, punch. It works really well because it's very narrow and doesn't punch holes too deeply through the foam, so it'll make a nicer hole. There might be some weird reflections here, but what I'm going to do is I've got all the spots marked out for where the airports I'm going to use, and this is my sacrificial piece here. I'm just going to line it up by eye so that I'm sitting on top of it. Simply just take the punch, center it over that hole, and what's nice is you can kind of see down in this little slot here, you can actually see where the punch sits over that hole. And then it will kind of want to wander a little bit, so you have to just kind of force it down and keep it in place, and then just a couple of taps, and you should have your airport right through the middle here. And what I found that actually works the best, I tried cutting the face of a couple of them, and then trying to punch through, just because the punch is wanting to kind of float through the foam and isn't exactly hitting the middle of the airport. Kind of missed the airport just a little bit right there, but for the most part it's doing pretty good. The only thing with the punch is that if you don't finish and go all the way through, you'll have a little bit of hangout here, and then I don't want to tear that, so I'm just using an X-Acto knife to kind of finish the cut, and then I take a punch, force that through. This particular awl has a shoulder on it, and that actually works pretty good for pushing the paper back in, or you can just use your finger, and that will help smooth that edge back into the foam board. When we take our light, our LED, and when we come through the back, I'm going to end up gluing all of these to the back of the board to where they just come through, and then they'll light up. So we'll get something like that. We'll want to play around with these when we actually glue them in place, and we'll probably end up pushing this paper back in just a little bit around the light. Maybe I'll make a tool for it or something that'll help push that back in so that it looks a little bit better. Yeah, something like that. We'll glue them into place. And the distance on some of these, like this would be a good distance because they're about that far apart in the string. But when we get to the longer ones, we'll have to end up cutting them and putting some splice pieces in between. So what you have here on the back of the LEDs are the positive power, the ground, and then a communication line. These have little, these LEDs have circuit boards on them, and they're addressed by the position, and that's how we can program an individual LED for an airport. Well, hopefully you have your board already assembled, and please remember that if you're going to extend the LEDs, if you're using these pre-wired looms, that you need to keep track of which side you're cutting to make sure you're putting them back in the same spot. Because just like the power and the ground for these LEDs, they also have a data in and a data out. So if you're going to use the Kyle Harmon kit, make sure to test your LEDs before you start doing the programming. So, and that's what we're going to do here. I'm going to show you where to go to get the information, and I'm going to preface everything by saying I am not an expert on programming these devices. I have just enough knowledge to be dangerous. But if you ever get into a pinch, make sure to Google your error codes, and you'll see lots and lots of documentation for a lot of these projects are online. Sure, you could go out and buy an LED map that's already made, but the problem is that you're gonna have to have a cookie cutter map, and they're gonna be quite expensive. I'm probably only into this map for the map and LEDs and all the equipment, probably $100, and then maybe another $100 for a nice frame. So $200, and I have a really oversized map that's customized the way that I want it. So as far as the programming, we're going to have you come over and look over my shoulder, and I'm going to show you the websites and the information to get your project programmed. Now, outside of buying these METAR maps outright with everything already included with the lights and everything's programmed and you just got to plug them in, there are limitations because they only offer certain areas. So if you want to customize anything, you're going to want to make your own map. Now there's lots of places you can go to get these DIY METAR maps. One specifically, actually it's in the URL for the website. It's DIYmetar.com. This guy sells a kit with different types of lights, and everything's pretty much all packaged together for you. I used a kit that was put together by a gentleman by the name of Kyle Harmon, and you can find the information on this at led-sectional.kyle, K-Y-L-E, harmon.com. And he lists in order like all the process for putting the board together, connecting the lights, and then there's a section in there about the hardware for the Arundu device that he has. Here's the information on the kit, and in the kit is this development board which is specially customized to this kit. You can also get a There's an ambient light sensor that you can attach to this, and I haven't quite gotten mine to work out just yet, but there are settings inside of the program that you can select to make that ambient light sensor work, and then in the software. So pretty much this section that we're talking about right now is just in the software. Now there is a program that you're going to want to download onto your computer, the app for Arundu IDE. So this is what the icon looks like for the Arundu IDE. And essentially, this ESP board is the same as this WE-MOS D1 mini light. They basically use the same programming hierarchy. Whenever you see one with the other, you can assume that it's the same chip. Now it's time to program the actual chip itself. So you want to connect the chip to your computer, and when I mean chip, actually talking about the actual microprocessor. I did have to install some additional libraries, and this was a very fiddly bit. Part of this was trying to load the software and getting error codes, and it would basically tell you what you were missing. So you just have to come into this library section here. So there are 3 libraries you're going to need for this. Put them up in the search here. You're going to need this ESP8266 Wi-Fi.h, fast LED.h, and the vector. Those all need to be installed into your Arundu IDE library section. Searching for the WeMOS, I need to install the ESP8266. I believe there was a couple other libraries that I had to install, but you would find that when you try and load and it gives you an error, it'll tell you what it's missing. And then basically what you do is you just copy the error. So you can either navigate through his GitHub, and it lives, look for this LED sectional INO file. At the bottom of his page here, here's the direct link. So basically you want to download this file right over here in the corner, save it to a known location, and then Command A or Control A will select everything, and then Command C for copy, and then we'll come up here, highlight all this, Command V will insert it all into your sketch. So you'll have all of that right here. Now the areas in particular to pay attention to, there are some limits here. The actual number of LEDs will be the number on your particular string. Now if you're selecting for wind thresholds right here, you want to select whatever your wind in knots, and that will actually show up as yellow on your map. This section right here is how often you want the loop to update your map. So it's right now it's set for 15 minutes, which is fine. Now he has the light sensor turned off, but if you want to turn it on, you would change this to true. And all of this stuff is editable, by the way. You can edit anything in here. The first thing you want to do is you want to set up your Wi-Fi so that your map can talk to your wireless at your house. So whatever you have for your Wi-Fi, you're going to want to come in here and put in my Wi-Fi and this is going to be whatever your situation is, whatever your Wi-Fi is, how it's set up, that's what you're going to edit in here. The next section is all of these lines in here are going to be in order from the way you've mapped them onto your map. Starting from the very first LED will be the first line up here. So what I can tell from the way he's written his program, these first 4 LED lines are for a legend. If you want to set up a legend and have it
marked as this is, for those that don't know the difference between all the different colors, is the level of category for the METAR. So green is VFR, blue is marginal VFR, red IFR, pink is low IFR. Yellow would be the wind speed, and I'm not exactly sure what happens with the lightning, as we don't really get much lightning storms out here on the West Coast. I'm kind of curious if anybody's going to do one of these maps that lives in the Midwest or back east. Please let me know how this lightning feature works, because on the West Coast, we don't really get a whole lot of lightning strikes that would trigger this. I've had it turned on, but I have yet to see it actually work, because we don't get lightning storms like they do back in the Midwest or on the East Coast. Make sure you put in the full identifier. So for all the airports in the United States, it'll start with a K, kilo, and it'll look something like that. You'll have to go down the entire line. However many lines you have are the number of LEDs that you're going to use. And then I believe the server that it's going to reach out to, which is right here, aviationweather.gov, which is it's what's called an API. It's how websites query information and give that information to other applications. So an API is an application programming interface. This is how programs communicate over the internet to transfer information from one centralized location out to many other applications. So for aviationweather.gov, that's where features like SkyVector, ForeFlight, anywhere that you would have a map that visually depicts weather will query the information that comes from this website. You'll want to save your file with whatever given name you want to use, verify the program, and you'll see the compiling going on here in the lower right hand corner. Don't get too freaked out on some of these error codes, because a lot of these are specific to features that may not be set up in the program. Once that compiling is done, that's just verifying any major errors, and as long as you get white type down here, you're good to go. You'll have to set the port once you have the board connected to your computer. You won't see it listed in any of your other devices, but open up the drop-down menu here. I have the right board set for the Wemos. You'll have this USB serial port will pop up once the chip is actually connected to your computer. Once that's all been selected, you can hit the upload button, and it will yet again compile the sketch. So it's building it specifically for your chip, and then you'll start seeing it writing to the board. Now, as long as you don't get any red letters or red errors, you should be good to go. Once it says done uploading, you can disconnect your module, and you should be good to go once you hook it up to your map. So I hope you found some of this information helpful and informative. And if you do decide to create your own METAR map, I wish you the best of luck. And with that, we'll see you on the next one. May all your flying be good flying.
So I went and had. This is the steps that I've had to go through. This is how I'm going to go about doing it. Blech.